Have you ever wondered about the road not taken? That job you didn't accept, that person you almost spoke to, that tiny decision you made this morning. What if, in another reality, a version of you made the opposite choice? Imagine a universe where you took that job and now live in a different city. Picture another where you said hello and your life unfolded along an entirely different path. This isn't just science fiction, it's a real possibility from the wildest corners of physics. The idea, countless versions of reality exist, branching off with every decision. Our universe might be just one leaf on an infinite tree of realities. In some worlds, the differences are subtle, a different coffee, a missed bus. In others, history itself is rewritten. The journey into this idea begins not with telescopes, but with microscopes, peering into the quantum world. Here, the rules of reality break down. Particles can be in multiple places at once, behaving as both objects and waves. In this quantum weirdness, the seeds of the multiverse were planted, challenging our understanding of what's real. So, as we explore, keep an open mind. We're venturing where science meets imagination. To grasp parallel worlds, we must shrink to the quantum realm, where things get truly strange. Imagine a spinning coin. While it's in the air, it's both heads and tails, a blur of possibilities. This is superposition. Before we measure it, a particle like an electron exists in all possible states at once. It's not just philosophy, it's a mathematical reality, described by the wave function. The wave function lists every possible outcome and their probabilities. Only when we observe the particle does this cloud of possibilities collapse into a single reality. Measurement forces the universe to make a choice. This transition from all possibilities to one actuality is a central mystery of science. What happens to the other possibilities? Do they vanish or go somewhere else? For decades, physicists thought only one outcome survived, but a radical idea emerged. Maybe every possibility becomes real, each in its own universe. This is the leap that opens the door to the multiverse. Every quantum event could create a new universe. The implications are staggering. In the 1950s, physicist Hugh Everett III proposed a bold solution to the quantum puzzle. What if the wave function never collapses? What if instead, the universe splits with every quantum event? Every possible outcome becomes real, each in its own branch of reality. When you measure an electron, you become part of the quantum system, splitting into different versions, each seeing a different result. Both outcomes happen. Both are equally real. Reality becomes an endlessly branching tree, with new worlds created every moment. There are worlds where you turned left instead of right, or where dinosaurs never went extinct. Everett's idea took quantum math at face value. No mysterious collapse, just a multiplication of realities. Observation is just another interaction causing the world to branch. While unproven, many worlds is considered by many physicists to be the most straightforward explanation for quantum strangeness. It paints a cosmos far grander than we ever imagined. Every possibility is realized, somewhere. The idea of many worlds isn't just quantum, it's cosmic. The Big Bang Theory says our universe began 13.8 billion years ago, but what came before? Cosmic inflation suggests the universe expanded rapidly from a tiny patch, driven by a powerful energy field. This explains why our universe is so vast and uniform, but inflation might not have ended everywhere. Our universe could be just one bubble in a vast cosmic ocean. Each bubble could have its own Big Bang, its own laws of physics, its own destiny. The cosmological multiverse is different from quantum many worlds, but both could be true. Imagine an infinite ocean of bubble universes, each with infinite quantum branches inside. The scale is almost beyond comprehension. The double-slit experiment reveals quantum strangeness like nothing else. Fire electrons one at a time through two slits, and you get an interference pattern, evidence they act as waves, not just particles. Each electron seems to pass through both slits at once, exploring all paths simultaneously. The wave function creates the interference pattern, collapsing only when the electron is detected. But if you watch which slit the electron goes through, the pattern vanishes. Observation forces the electron to choose a path, behaving like a particle. The many worlds interpretation explains this cleanly. When you measure, the universe splits. In one world, you see the electron go left. In another, right. Both realities exist, but in each, the interference is lost. The act of observation doesn't destroy possibilities, it divides them. Every measurement is a branching point. The experiment shows reality is shaped by our interactions. The quantum world is a landscape of endless potential. Our choices carve out the path we see. If other universes branch off from ours, why can't we see or visit them? When the universe splits, the branches become completely separate, non-interacting, invisible to each other. It's like tuning a radio. Many stations exist, but you can only hear one at a time. Once a quantum split occurs, our reality becomes decoherent with the others. We're tuned to our universe, unable to perceive the rest. This isn't a physical wall, but a fundamental barrier of quantum mechanics. The wave functions no longer overlap, so the worlds can't interact. That's why the many worlds interpretation remains a hypothesis. Its central claim lies just beyond our reach. Scientists haven't given up on finding evidence for other universes. One clue could be a bruise in the cosmic microwave background, an unusual cold spot, perhaps from a collision with another universe. While intriguing, such anomalies could also be statistical flukes or unknown physics. The search continues, pushing the limits of observation. Quantum entanglement offers another hint. When two particles are linked, measuring one instantly determines the other. Many Worlds says each measurement splits the universe, preserving correlations across branches. Theories like string theory predict extra dimensions and a landscape of possible universes. If experiments at places like the Large Hadron Collider find evidence, it would support the multiverse idea. For now, these clues are speculative, but the search is on. If every choice creates a new universe, does anything we do matter? It's tempting to feel insignificant, but the many worlds view actually amplifies our responsibility. Every choice you make gives birth to a new universe. Your actions echo across realities. Your choices are the seeds of entire worlds. In a multiverse, your decisions are the mechanism by which reality branches. You are the nexus from which new timelines are born. The meaning of life isn't found by looking outward at infinite worlds, but inward, at the one you inhabit. The other versions of you are not you. Their experiences are their own. Your responsibility is to the person you are here, in this branch. The existence of other worlds doesn't diminish this one. It highlights its uniqueness. This is your universe. Make it count. Are parallel worlds real? The honest answer, we don't know. The many worlds interpretation and the cosmological multiverse are elegant but unproven. We have no direct evidence, yet. Science demands testable predictions, and until then, these ideas remain hypotheses. Still, the search is one of science's greatest adventures. Physicists are pushing the boundaries of theory and observation, designing new experiments, and scanning the skies for cosmic clues. The question has grown. It's not just about life on other planets, but about other universes. The journey itself is a testament to human curiosity. Whether we find proof or not, the pursuit enriches our understanding of reality. It humbles us, reminding